Yeah, the last one we did, my phone rang.
I know.
Like, oh, you watched it?
I did watch it.
No, you did not.
Hey, you never know if somebody's going to ask a question.
You were
in
one
there,
of the
right?
5 people that watched it.
I might have been.
Yeah,
I watched
okay.
it yesterday, actually, so maybe, yeah.
I don't even know how many views we got.
What day is
5.
it? It's Tuesday, right?
Tuesday.
Yeah, I watched it yesterday
Okay.
in the morning because I was like, oh, I should probably get familiar with the most recent episode.
I gotta
make sure.
Okay. Well, I gotta shut my phone off because it rang like right.
But
in
I
the
couldn't hear
middle
it.
of the last time.
I didn't hear
Oh,
it
you
on
couldn't
the
hear it.
recording.
Okay.
No.
Well, I guess these are sound canceling
Yeah,
microphones.
because you talked about it, and I was like, oh, I didn't even know that you did.
Well, it was pretty loud sitting in this seat.
Okay.
Like it rang and vibrated and everything. I was like, oh, that's slightly embarrassing.
Yeah.
Okay. Well, now I'm going to start off and say you are Matthew Lawrence.
Man, Matthew. It's like I'm talking to my parents, but that's okay.
And you're here today. So just to do a quick introduction, why don't you kind of tell us who you are, what you do, where you work, if you can tell us that. Can you tell us that?
I think I know that, yeah.
Okay. Go ahead.
Yeah, so Matt Lawrence. I'm the Senior Director of Energy Engineering Solutions at Kiewit, right?
Okay.
So what does that mean?
Yeah.
Kind of got 3 things that we're focused on, right? One is supporting all of the engineering and design systems, mainly based around Hexagon, so I know you're very familiar with those tools, right?
Oh, yeah.
The second one is kind of building the future of execution, so we've got some automations and AI stuff that we're doing around there. And then the third one is our digital project execution team, which focuses on kind of our consolidated data environment and bringing all of the data together from engineering and then downstream so that everybody on the project can kind of have a common view of the execution.
Oh, that's awesome.
Yeah.
How long you been doing that?
You mean that specific thing?
Yeah. How long you been working in kind of that capacity?
Oh, I mean, I've been doing
the current role you're at right now.
Well, I mean, I've been at Kiewit for 6.5 years. And so I was
Has
brought
it been
in.
that long?
It has been that long, and I mean, I don't know if I should admit it, longest place I've ever been, but that's so. Yeah, no, I came in to do like the oil and gas specifically.
Okay.
Right, focusing in that market, and then through some different moves, not of my own making, I ended up in this role. So
How
I've
long
been doing
have
this
you
for about,
been in
maybe
the
about
industry?
3 years in this role, but in the industry,
Yeah.
I won't tell you the year I started, but I'll say I've been doing it at least
okay.
25 years.
25 years?
25 years.
You don't look old enough to be doing 25 years.
I know, right? But
25 years.
yes.
Wow. So what did you start out as? Getting in the industry like
My degree is chemical engineering
chemical engineering
from A&M.
So did you start out in chemical engineering?
I did. So I did actual process work, right? So
Oh, that's
what
awesome.
I started off doing, and then first day they gave me a pump calc to do, and it was this manual spreadsheet, right? And so I went off and did it, and I took it back to my lead the next day, and I was like, all right, so now you can give me the tool that we actually use. And he's like, what are you talking about? And I was like, well, this had to be the tool that you gave people to just like learn the fundamentals, right? And he's like, no, look, that guy's using it, and this lady's using it. This is the tool. And I was like, this is insane. And that was kind of the beginning when I was like, there has to be a better way.
It's got to be a better way.
And so it's just been a journey. And, I've had a few starts and stops along the way, right? Like sometimes you get onto the technical or the technology side and you're like, I want to go back and do execution again. And so you kind of wind your way back there. But for the last decade at least, I've been doing really more technology focused from the execution side.
Okay. How technology like interfaces or supports the execution side, would you say?
Yeah, kind of both, right? So figuring out how to drive execution more efficiently, higher quality through the use of technology.
Okay.
Yeah, and
okay.
I mean, sometimes it's just using the systems out of the box, right? So, producing drawings from the model more effectively or something like that. But then others, it's taking the data that exists underneath and then figuring out how to maybe apply
utilize
some smarts to it to do things a little
Nice.
more effectively.
So I'm gonna do 2 plugs here, and you're gonna have to forgive me because I don't really know too much about it.
Yeah, no problem.
But I do know that you went to Italy
I did.
in September last
September,
year,
that's
and you
right.
did a presentation at a major like digital twin conference. Is
It's
that what that
actually a
conference was?
big LNG conference.
LNG.
Mm-hmm.
Oh, I did
Yeah,
not know
and
that.
so they had a focused area on like AI in energy,
Okay,
and so that was
that was the
the
track you were
session that
on.
I got to present
So
in.
can you give us a little like
Yeah, of course.
little detail of what you presented on?
Yes. So I presented on a solution called CADE, Kade, stands for Kiewit Algorithmic Design and Engineering, right? And so,
Now I have all kinds of questions.
yeah, and the algorithmic is very important, and I'm
Okay.
sure we will talk about that. But at a high level, we take a process flow diagram and a heat material balance, sized equipment list, and a plot plan, and with the push of a button, we get a 3D model, right? It does a lot of the process engineering for you up front, and then through that automation, routes all the pipe, creates the entire model, and gives you quantities, and then ideally, which we haven't totally wrapped this up yet, but it immediately gives you the total installed cost for that facility as well.
So like a whole feed?
No, I would say if it doesn't exist on the PFD,
Yeah.
it probably doesn't exist in our model yet.
Okay.
But there are things that we are doing to extend
To
that.
extend that.
Exactly.
Okay.
So the initial step was just get it working, right? And
Yeah.
get that content working. And then as we start to look at, okay, what are the extra things that we could be adding that we know about, right? I mean, taking, well, no, go ahead.
Well, I was gonna say, so your idea, I guess, there is it to eventually get to like a feed package to where you can like
Yes.
off the shelf pick and choose your variables, if you will, like what process you want, what you're trying to make, what you're
That's
trying
right.
to produce,
That's right.
right? And then it auto builds that.
Yes. And
That's pretty impressive.
I mean, we kind of started at the end and then worked our way backwards.
Okay.
And so that's why it's taken us, I would say, a few iterations to get there. We basically started in the detailed design tools and said, okay, what does it take for me to get a smart plant project at the end of the day, right? I want a 3D model in smart plant.
That's an interesting approach.
And then I want to go backwards and say, what is the least amount of data that I can put in to get that outcome?
Yep.
And drive automation to get me there. And so we've kind of distilled it down to the bare minimum that you need to put in to then drive that automation to get to an actual smart plant model. And the main reason we wanted it in smart plant was ultimately that's where we're going to need it for the next phase of the project.
Yeah.
So if we do this right, that's the starting point.
That's the starting point.
And you don't have to redo it, because how many projects have we been on where when you're moving from one contractor to another or one phase to another, there is just a rework phase where you are taking that previous product and converting it to your system, moving it in. Because even within your own companies, right? Like you say you were doing the estimate and moving it to a detailed design project, typically you're going to use a much less sophisticated tool to do estimating.
Yeah.
So it's going to give you a picture, it's going to give you some quantities, but it's not going to really be the fidelity that you need to be able to start with that next phase. And even if you do, the people in detailed design don't trust what the estimators give them anyway. So they're going to say, I don't know what your basis was, I'm going to redo it. So this kind of takes all that off the table because you know what the basis was. The automation only produces what was put in. It only gives you an output that matches that. And the other thing that kind of drove this was we can use all of the specs, all of the standards, everything that we
Throughout
built,
the whole life
catalog.
cycle.
Exactly. Why wouldn't I just use the pipe specs that I already have to route this pipe? Why wouldn't I use the steel catalog that I'm going to use to build it? Right? All of those things that we've already built that are, intended for detailed design.
Well, and then
why wouldn't we use that?
That way, if there's changes, you're just making tweaks.
That's
to
right.
them. You're not
That's right.
starting over every time from
That's
scratch.
right. Or when the catalogs change.
Or when the catalog.
So the next time I pull the project,
Yeah.
I'm using the current catalog. I mean, most people take snapshots, and you end up with these, these pictures in time of what the catalog or what your details were. But those are going to mature. Those are going to, they're going to change as technology changes, right? I mean, I remember being on a project at a previous company maybe 15 years ago, and we were doing a front end design. And the client looked at kind of the control system that was put in place. And they said, why are you doing it this way? And we said, oh, this is how it's done. And they said, yeah, maybe 15 years ago. And it's like, oh, that was the last time we actually had built something at that place. So it was the last time we really saw the field and what was actually happening. But conceptually it worked, but it did not match the reality of where the industry was. And that's what's going to happen even with all of your standards, right?
Yeah. That's an interesting approach. You said earlier that you kind of started, and you can correct me if I'm wrong here, but you kind of started with the design tools and the deliverables that you wanted to get out of the system, and then you kind of worked backwards.
That's right.
Which I feel like the industry doesn't really take that authoring type approach and that deliverable type approach in that aspect from the data perspective.
That's right.
So I feel like that's a unique idea and kind of a shift in the way that's produced. I actually think that's probably one of the only ways you could actually be, I don't want to say one of the only ways you could be successful, but that sounds like the best path to success in trying to automate the package, like what you're trying to do.
Unless you want to do it 3 or 4 different times, 3 or 4 different ways, and hope that it all comes together at the end. Because, I mean, when you think about like some of the engineering that I was saying we're automating, right? Because we're using the smart plant data structure, right? I mean, so for the PFDs, we're using smart plant P&ID for that.
Oh, that's interesting.
Right? And so it's using the smart plant P&ID data structure. So there's no reason that we can't apply the same logic that we have to P&IDs.
Correct, yeah.
You
just build on top of it, right?
Exactly. Yeah. I wouldn't want to, because I can represent so much more information compactly in a PFD than I can in a P&ID. I don't want to have 300 drawings to create the model. I want to have 30, right? Yeah. And so that's kind of the concept of why we want it in the PFD, but there's no reason that as you expand into the next phases and you actually do have P&IDs, you can use that same underlying data, you can use the same logic to apply on top of that same data structure and drive the same engineering automations, because it's all the same data.
That's pretty impressive.
Yeah.
How far along have you gone down that path? Like what stage are you currently in?
So I would say that if we had to give it an FEL or a percentage, we're probably close to an FEL2. We're probably able to do about a 25% model.
That's still a lot further along than I thought you'd be. I mean, I'm being honest, right?
Yeah.
That's a lot further along than I thought you'd be. So that's good.
I'd say, it's taken us about 3.5 years to get here.
Okay.
And I mean, really not with a large team. I won't say exactly how big the team was, but not a huge team to get to that point. And like I said, it was iterative, because when we first started looking at it, it was like, okay, well, we know we want to get here, and we know this is the data that we want to put in. So what if we just start with Excel, and you have to fill in the Excel and consume that, and will it produce the result that we want? And the answer is yes. And then it's like, okay, well, could we produce that Excel from the intelligent systems that we have and make it a standard report that comes out? And then we just consume that. And we proved that we could do that. And then it was, okay, well, why wouldn't we just read straight from the database using the APIs, right? Instead of having to generate a report, why wouldn't we just get to the data through the APIs? And we did that. But then some of the stuff that we realized was, part of the challenge, I think, for this industry is we, as an industry, I think you already kind of pointed it out, we don't care about data. We say we do. Yeah. We say we do.
You say you do.
And there's a lot of data there. I think
it's almost like a buzzword.
Well, every document contains data.
Yeah, that's
Is it usable data? Is it good data?
Yeah.
But ultimately, we don't care, I would say, about the data in the database if we have intelligent systems. And it was funny because Mike kind of made this point on the last episode where he was talking about how AI is kind of preventing us from, or making people think that they don't need the sophisticated tools because you can use a simple AutoCAD and then you can apply an AI to it, and now it will create structured data that then you can use, and hopefully everything matches. And something I've been thinking about, and I'm sure, hopefully you're not sponsored by some of these companies, but but I'm gonna say I've been thinking that the that AutoCAD and the transition to AutoCAD may have been one of the worst things that ever happened to this industry.
That's interesting.
And I'll tell you why. Because
Oh yeah, you got to tell me why on that
we
one.
have to. You can't just leave it open ended.
Yeah,
It's
you
like
can't do
you're
that.
going to get calls and it's not going to be good. But I mean, I don't think they can dispute this. So, you know, when you think back to what was the transition for AutoCAD, right? It was taking what you were doing by hand on paper or
Yeah,
Mylar or
Mylars.
whatever, right?
Yeah.
And you converted that to doing the exact same thing digitally.
Correct.
Right? So drawing lines that represented things, but not really intelligent objects.
Correct. It just helped you draw those better.
That's right.
Is basically what it did.
Exactly.
It,
And the problem, as I see it, is that when the next iteration of smart tools came out, the people who had gone through the AutoCAD conversion said, I've seen this before. I know what this looks like. And they treated that next iteration the way that they did AutoCAD. It was just a new flavor of drawing by hand. And so nobody really took advantage of the capabilities or the concepts that come with a database-driven solution.
it's interesting that you say that because I've had that same discussion with other people because I kind of am at the same point. So you went from Mylars to AutoCAD, and that was a big transition, right? But like at the end of the day, like you said, you basically just redrew what you had on that Mylar drawing into
right.
an AutoCAD system, which is good. I mean, it's easier to do. You can use attributed blocks. You can gain your efficiencies.
Yes,
But now the transition is not the drawing or the document anymore. It's the data behind it.
that's right. That's right.
And that is a different transition than drawing to drawing.
100%. But because the systems have historically stayed document-centric,
Yeah.
it has kept people in that same mindset that they had originally.
Well, and that's my whole. You said the sponsors. We don't have any sponsors.
No, I'm just
bro.
saying, well, you're not
We
going to
sponsor
after
ourselves.
this.
That's my whole argument on the what we call the engineering like data ecosystem is where does document control actually fit into that? Because
Right.
at the end of the day, if you're using enhanced authoring tools
Yes.
like SmartPlan or
Yes.
Aviva, right?
Yes.
Anything that has that enterprise data on the back end, if you're using that to actually author that, well, the documents, I don't want to say are not important. They're not as important because they can be recreated straight off of the data.
That's
like
right.
you could go and blow away.
That's right.
In SmartPlant PNID, you could blow away a PNID, the file PNID, and then just from the database recreate it.
Yes, exactly.
So then it becomes a question. Okay, well, how does document control fit into that? Right?
That's right.
And the argument that I run into there is that there's certain attributes within a facility still that not all of those deliverables have an actual authored like enterprise level data source.
Yep.
So like equipment specs is
Excel,
one, right?
Excel data sheets. How
Yeah,
many of those?
right.
I mean,
like
yeah.
equipment specs. There's
Right.
not like
That's
like a instrument or a PNID equivalent for
That's
an
right.
equipment spec
That's right.
yet.
Right.
And
there should be.
But
right?
there should be.
There should be. And so if we go back, because I kind of got us on a tangent here.
Oh yeah, you
but
got
if we
us
go-
on an interesting tangent.
If we go back to what I was saying about how we don't really care about data, that was kind of a very big realization for us, right? Was that even if we could get to the data in the database, if it wasn't complete, if it wasn't, I would say, mature, right?
Mm-hmm.
Then somebody could hit the button and start the process, and you're just wasting everybody's time, wasting the resources because, number one, it may not run because it doesn't have everything that it needs, and then number two, if it does run, whatever it produces may not have been what you wanted because somebody was still having a work in progress. And so that was something that we had to kind of work through was how do we capture and inform of where we are in the data life cycle so that we know when we're ready to push the
It's
button.
hilarious. It's running right down the same path. I have a little bit of a story, I guess, that kind of fits that. It was because I've been in the industry Not the same amount of time.
Yeah.
That's sad.
It's not sad.
No, I'm old.
But I mean, it is sad when I think back that I'm
Makes
like,
me feel
wait,
old.
I remember seeing people that
Yeah.
were my age, and I was like, holy crap, that guy's old. And then I look, and I'm like, that's me now.
That's
not
me.
good.
Yeah. This is kind of like I just realized that right
Yeah,
now.
yeah.
Anyway, the story I was gonna do is one of the first projects that I did using an intelligent design system, right, like a smart plant system, was very interesting, and there was a shift that was happening, and I could see it happen, because what you get is when you're doing it the traditional way, and the traditional way now is like the AutoCAD or a CAD based way.
Yes.
That's the traditional way.
Right.
When you're doing it that way, your productivity can seem very high right off the bat. Right? Like if
Yep.
you got to crank out P&IDs, boom, day one, you're cranking out
That's
P&IDs.
right.
So your productivity looks real high. And what I was getting dinged on is, why aren't you being as productive as the other guy? And I said, hey, hold on. And I had a good management team that trusted me, right? But I said, hey, hold on. I have to build the data foundation, and then it's going to come.
Yep.
But watch it come.
Yep. Yep.
Right?
Yes.
And they trusted that, and it was good. I did an okay job, and they believed it, but it was difficult at that time, because they were like, hey, this guy is dumping out drawings. And I said, yeah, okay, I'm building.
Yep.
So I'm starting down here. But eventually what happens is you cross that line of productivity, and then your productivity goes through the roof.
And your quality.
And your quality.
Because that's the other part, is they can pump something out, but how good is it?
Yeah, that's right.
Because I'll build on your story. I have another story that goes with it. Dovetails very nicely, right? So at a previous company.
I am going to say that you're right on the quality.
Oh, for sure.
Because that's where the real gains happen.
That's right. That's right.
Because what happened, I stole
No,
you
go
just
ahead.
for a second
Come on.
here. Because what happens is, not only I need a whiteboard, bro. Not only do you converge at that productivity line, but what happens is then changes happen on the project.
That's right.
And when you have to make a change,
That's right.
and you have a good data foundation built,
Yep.
you can make that change once.
That's right.
And
And apply it
affects
everywhere.
everything.
That's right.
Whereas when you're in a traditional CAD base, you have to make that change 7-8 times.
Yes. And you might be able to write something in Lisp or something like that maybe
gets it, but the question is does that change actually get picked up 7 or 8 times?
Well, or you're changing, some set of characters or something like that, and it may appear in places that you don't expect it. So it's not really the attribute that you're changing like you would be in a database-driven system. You're changing some combination of characters. And you're hoping that this is what you actually meant to do.
Yeah, so the quality is a big point.
Oh, yeah, for sure. And so that's where I was going to go. So at a previous place, their standard tool set was AutoCAD. And we were in the middle of converting to SmartPlant P&ID. And we went in and met with a client. And, they were very interested in kind of working with us on their next project. But they said, we've already been working on this. We really just need you to kind of carry it across the finish line and build it. And the set of P&IDs that we're going to give you are going to be the best P&IDs you've ever seen, right? Because we've been working on this for 2 years. So they gave it to us, and we said, well, we still want to convert it to SmartPlant P&ID because we think we're going to get more value out of it longer term. And they said, if you want to do that, it's at your own cost. Don't throw that into the estimate for what we're doing, but that's fine. So we did that. We converted it. And about a month later, after we'd redrawn all their P&IDs, we came back and we said, hey.
You'd redrawn them in SmartPlant?
Yes.
Okay.
And we said, hey, you only gave us 37 pipe specs, but you've got like 43 on your P&IDs. And they said, no. We said, where's the other 6? They said, no, there's only 37. And so we pulled up this drawing and said, well, what about this one? And they said, oh, that's a typo. And we pulled up this one. That's a typo. They had 6 typos just for pipe specs, right? And they said, maybe you redrawing it in SmartPlant P&ID could be of value because maybe it's not as good as we thought. And that's the whole point. The quality, you don't even know. An O, a 0, you think you're getting it right. It's not right.
Well, it's interesting that you talk about that in doing that drafting. So a lot of what I do and what the business I am in is like data foundation building, right? And
Yep.
so we go to a lot of facilities and we actually help them become more data centric. And some of the times what happens is that you find a lot of errors in their current
Yes.
information, right? Because they'll have like a PNID or even in their wiring, right? They'll have like 7 or 8 different variations of a wired panel. Okay.
Yep.
Well, when you migrate that into like a data centric environment, you can very quickly tell where those variations are.
Yep.
When they're in their own document in a document control system, you have to just know that like instinctively,
Right.
right? And that's where you get those guys that have been in the field for 10, 15 years that worked at that plant or whatever. They just know, oh well, I'm looking at this document, it's wrong. Okay, that's great. I have new guys that are coming in that I have to train up. How are they supposed to know,
Right. That's right.
right?
I mean, just make the same mistakes.
Yeah,
That
like,
doesn't seem right.
that's not
No.
interesting.
And especially when we've only got 5 to 7 years before you start losing all of that experience. I mean, we've lost a bunch of it already.
I
but
think
it's-
that's happening now.
It is, but I'm just
Right.
saying this will be like the end of
The
it.
the
right?
end of it.
Yeah.
Yeah. You got about 5, 7 years.
Yeah.
Yeah, but I think you're losing that now.
For sure.
We can talk about that in a minute because I
Yeah.
have a whole conversation
yeah.
about that too, that I can go into some different rabbit holes. The one thing though that I did want to ask, so you're building that and you're 20% kind of like FEL2 whatever.
Yes.
Your long-term vision for that then would actually to build that whole feed package. How do you see that though building into like the actual detailed design and engineering? Like
Well-
you just continue to build on that foundation?
Yeah. I think the one place that we think has the most challenge is like piping auto routing.
Okay.
Right? Because there's so much, nuance and kind of, I would say, best practices that need to be built into those types of systems. When you're letting it kind of just do its own thing, trying to build those rules is quite challenging. I think there's some stuff on the market that is interesting, but I think that's the place where, if we had to say, what are we going to have to do rework on as we mature the design? I think piping is probably the place, because our goal right now is to get representative quantities, right?
Okay.
Representative routes. Is it picking the exact way that a human would do it? No. And are we spending the time to try and make it do that? No, because for us, FEL2, I would even argue FEL3, if we're getting it close enough,
Yeah.
it's probably close enough. Is it perfect? No. But is it going to be the end of the world if it's slightly wrong? Also no.
Also no. Yeah.
And so I think that's part of our, part of the challenge. But for sure, being able to mature the structural, right, concrete, things of the racks and structures, things of that nature, there's zero reason why we shouldn't be able to build upon that early foundation as it matures through the design, right?
Yeah.
I mean, people have to do that already. That's how you end up with structures that look like monuments in the field, because it's like, well, we need to get out of the ground. We need to have this thing built. And so we're going to over-design the crap out of it, right? And then at the end, somebody comes back and says, well, why did we use so much steel? And why did we use so much concrete? And it's like, well, because we compressed your schedule by 3 months in the field so that you could get stuff done, and that costs more material. And so, you kind of have that balance there. But with that understanding, there's no reason you can't make these things happen earlier if you're willing to take some risk, if you're willing to put some extra stuff in. But ideally, what we're able to do is maybe tighten those things up so that you're not having to put as much over design, because you're getting the answers earlier, and you can start to tighten that up. It's the same problem that you have with modular design, right?
Yeah.
Like, you want to go to the shop, well, you got to have all that stuff ready so that the shop can do what they need to do. So again, you're going to have to do a lot of early things, maybe make some guesses, maybe put some factors on it, And if we can do these things faster, get to the answer faster, and get to a better answer, then maybe we don't have to have as much waste.
Interesting.
Yeah, but the goal is ultimately mature it through the design.
Mature it through
and
design.
So just keep expanding and say, okay, now how do we get to 30%? How do we get to 35, 40? Like, what are the things that take the most amount of effort from a tedious point of view that don't add value, so that we can let the engineers and designers focus on the places where you really need to sharpen your pencil.
Yeah.
Right? That's the goal.
That's the goal.
Yes.
Now, in that goal, the system would have to be open enough to allow those changes happening throughout the whole process, right?
Yes.
Which with a data-centric system that's possible to do. I think
that's right.
That's possible to do. So I think that's a good path to go down. I'm going to throw 3 wrenches,
okay,
maybe at you.
Maybe we'll see.
I don't know. The first one is AI.
Yes.
How do you think that AI will fit into that model and benefit it? Because I think AI could be a benefit to it, especially when you get into those later phases, right?
Yeah.
In doing some of that conceptual design, I think AI could definitely benefit there. But how do you think it would benefit?
Well, for sure. And when we say AI, right, to me, I would say there's 2 flavors.
Maybe we should define.
There's 2 flavors, right?
Okay.
There's the
Let's
generative, which is what I believe you're referring to, and that's
that
why
is what I'm referring
the
to.
A
Yes.
in CADE, standing for algorithmic. I mean, it's the old school AI. It is the intelligence that was learned through years and years of human effort, and then we have turned that into algorithms that do the exact same thing that a human would do. It does not guess. It does not make mistakes, right? It just gives you you give it some inputs, it will give you the same answer every single time, right? And so when it comes to engineering, I mean, to me, you have to have that level of trust with what's coming out of it. So when it comes to, calculating the stress, calculating loads, calculating line sizes, like, you need to know that it's not just guessing and giving you what it thinks is a good answer. It's giving you the right answer. So that's one thing, is that we already have a flavor of AI, but how does generative AI do it? I would say that, especially for what we're doing, layout generation.
Okay.
Right? So coming up with what the optimal layouts should be. So basically being able to, because one of the problems for people who try to do that now is that they don't actually know what the real quantities are going to be, right?
Yeah,
because they don't produce a model that actually reflects what that layout is, right? So it's like, oh, I'm going to move some stuff around, and maybe I can like sort of guess like what's connected to what and what are the distances, so I can kind of get some representative things. But we can actually generate thousands of layouts, give you the quantities, feed that back to an LLM and say, tell me, based on these constraints, like these things that we care about, what are the top 5? What are the top 10? Yeah. Where do we go focus? And then where do we start to sharpen up and say, here's the options that we have?
Now to do that, and then I'm gonna still it for a minute, because you kind of said it right, and you're talking about the right AI. But what I like to call that, I call it, instead of AI, artificial intelligence, I call it augmented intelligence.
Okay.
And the reason I call it that is because in order to do that, you have to have an SME or a person with expertise that knows not only what they're looking for necessarily, but knows the process that it takes to get it.
That's right.
Right?
That's right.
And so what you're doing is you're using that individual to say, hey, here are the parameters, here are the values, give me the top 5. And then it kind of gives you that top 5. And then that individual has to look through those and say, okay, well, I like the top 2, but change these parameters and do it again.
Yep.
And rerun it.
That's right.
Until they get a final one that they're comfortable with.
That's right. Because part of it might get exposed when you actually look at the model and say, oh, constructability is a little hard here. Maybe you can't capture all of the rules that would make sense for defining an optimal layout, right? So you
That's
need
right.
that expertise to still be looking at it and evaluating. I mean, we're going to be able to capture a lot of things,
Yeah.
but we may never be able to capture all of
Correct.
that knowledge.
Correct.
Yeah.
At least I don't think so within the next five or so years. Now I
Right.
know other people say they're different, right? AI is going to like run the world in 5
I
to
mean, that's
10
the
years.
thing. If that's what it's
Right.
really doing, then we're just wasting our time, right?
Well,
Like, because at some point, the machine is just going to be able to do everything, and then what does it matter who's writing the prompt, right? You could go get a 16-year-old that just is old enough to
Well,
work,
so-
and you can pay them, and they can
so
do the same thing.
That's my concern.
Yeah, or the AI will prompt itself. I mean, at some point.
So while I'm like on two different boats, right? In one boat, I'm right in what we're talking about. I think it's going to be amazing. I like the idea of augmented intelligence, where you
Yes.
still have that expertise in there, and they're still feeding it the parameters and the different sets, right? That they're wanting to get out of it, and they're still validating, I guess you could say.
Yes.
Right. What I worry is, and this is one of the worries that I have is now you're getting into a more practical, I guess you could say, use of it,
Okay.
right? So then, how do you train up the next generation to do that?
That is the problem.
Because that expert learned by actually doing
That's right.
those things.
That's right.
And so what you're actually kind of doing is that expert is then training that model
That's right.
to understand what he is looking for, she, whatever,
Yes.
right? But what they're looking for,
Yep.
instead of what you would do today is you would be training a new grad.
That's right.
And you would be doing that same kind of process, but with a new grad or
That's
with
right.
a high value resource center. And you'd be saying, hey, these are the parameters. This is what I want you to build. Like, come up with the idea, build it, and then let's review it.
Right.
But now you're not going to do that. Now that expert is going to do it to the AI.
Agreed. And I think that we're probably going to have to go back to what we saw in, I would say, the late 70s and early to mid 80s, right? Where you
Okay.
had places like Fluor, places like KBR, well, Kellogg at the time, right? That were training up, I would say, the talent for the industry. So Fluor had a piping school. How many people got trained at that, right? And they spread all over the place. But it was because they invested, because they knew they needed it. And so they
Yeah.
put these curriculum together to train these people.
And they invested in the people.
That's right. And yeah, they lost a bunch of them and it spread out. But if nobody's willing to do it, then there will not be a next generation, right? And same thing with KBR. They had systems school, and so they taught a bunch of people how to do systems engineering, right? And so, I mean, or Kellogg. Sorry, I keep saying KBR, but it was Legacy Kellogg that did it. And so the point is, I think that's what it's going to take is some of these companies that are reaping the benefits of this automation, because realistically, what this should drive is we should start seeing a lot more certainty around lump sum,
100%.
because the value of what we're doing
I agree with
isn't
that.
changing,
Yeah.
right? If only 2 or 3 or 1 company can do it at this level of efficiency, the value of the product has not been commoditized.
Yep.
So to get the same thing, good luck. Go down the street and you're going to pay and you're going to wait, right?
Yeah.
And so that value's still there. So you should be able to make good money selling those services, selling the product of those services.
Yeah.
For the same amount as what it would cost to do it manually. And once you've got that, you need to start reinvesting that into the next generation, building that curriculum, training those people up, because that is
Yeah.
how you're going to stay ahead.
That's
right?
how- that's
if
the
you don't
only
have anybody
way-
that can run this effectively, then it doesn't matter how good of a tool you have, because in 10 years, you're not going to have the workforce that can actually produce a high quality output anyway.
That's the only way that I actually see that working. I was listening to, I don't know if it was a podcast or an interview or what, but Jensen was talking something about this, the CEO of NVIDIA.
Yes.
Was talking something about that, and he was asked a similar question, and his answer was, well, what you're going to have to train those guys on that are coming up is how to work with AI and how to ask it the right questions. And I thought,
No.
okay, yeah, but how are they going to know the right
Exactly.
questions to ask?
That's right.
Especially in the engineering world, right?
Yep.
Because I got a whole nother kick, and we won't go down it, but I got a whole nother kick that there's different types of data. There's consumer data, and that's what the majority of the world works on, is consuming data. Like,
Yep.
like I'm going to build a profile on you,
Yep.
and then I'm going to consume that data to predict what you're going to do or what you're going
Right.
to buy or whatever.
Right.
In the engineering world, it's not consumer data, it's
No.
authored data.
That's right.
And that's different because there's a reason why it was there. The data was created in a specific way for a specific reason.
Yes.
It's not something that you can just consume.
Right.
You have to author it first.
And it's hard to predict.
And it's
because
hard to predict.
There's
yeah.
not a ton of authored data,
Correct.
right? Even if you digitized every facility that we've ever built,
That's right.
it probably isn't enough to train a model effectively to make the right guesses
I
100% of the time.
100% of the time. And yeah, I would agree with that. So then like I said, the question from that perspective is oh, those young guys are coming up in the world, and they're just gonna have to learn to work with AI to ask it the right questions. And I was like, okay, well, yeah, maybe at the beginning when you still have that SME, because he talked about that,
That's
right?
right.
Like the SME. And I was
That's
like,
right.
maybe at the beginning when you still have that, but as soon as you don't have that, if he didn't transfer his knowledge or their knowledge to that next generation somehow,
Yep.
they're not going to know.
That's right. That's right. And that's part of the challenge, because for the organization, the best thing is to make sure that that knowledge gets transferred to the technology, right?
Yes.
Because then you get a consistent output no matter who is there.
Who's there?
But the reality is there is always going to be human judgment required. There's always going to be that
Yes, I
human
think so.
input required. And if you don't get that intuition, that experience, that's where we're going to have the gap.
That's where we're going
Right.
to have that gap. Yeah. And I
mean,
think
we're-
that's going to be an interesting time within the next 5 to 10 years.
Oh, for
I
sure.
think it'll be interesting
sure.
to see how, like you're saying, are companies going to adopt some kind of apprentice program,
Right.
or how they're going to overcome that?
I think it really depends
Because
on...
AI is not slowing down.
No. And it depends on which company comes out ahead, right?
Yeah.
I mean, if you get the wrong company, then they are just going to double down and they're going to want to maximize profits. And you get that leadership that says, I'm here for today.
Yeah.
I'm going to drive this up. I'm going to get my
Yeah.
reward. What do I care if the company's there in the next 5 or 10 years?
Yeah.
I made mine. I squeezed everything out of it, and then I walked away. And, I mean, I hope that it's not a company like that wins the race, because I really think that
Yeah, that
that's
would
going to be
be-
a disservice to the entire industry.
Yeah. That would benefit the short term, but the long term would be
Right.
a problem. Now I go, okay, so that's good. That's why I call it augmented intelligence, especially at this stage, because I don't think you can do it without that
Right.
that expertise.
Right.
Even though I do think AI has gotten way more advanced, even within the last 6 months, 4 to 6 months, it's gotten more advanced.
Well, one other thing that I think is interesting, you say it's getting advanced. Obviously, it's more power. It's more, GPUs, right? I mean, to kind of drive that intelligence. I think that's the other thing for what we've built. You could run it on your personal laptop, and it would run in a day.
Oh,
You know what I mean?
yeah,
Like
yeah, yeah.
the level of GPU and horsepower that we need
is not
is a
high.
fraction,
Yeah.
and we can produce much higher quality
Yeah.
faster than what they can produce today.
I would agree with that. My comment on it getting more advanced is I've been dabbling with it for, I would say, 2 years now, which is a short amount of time.
Yep.
That's not long.
Yep.
But 2 years ago, it was. I would consider it. I'm gonna get blasted. I know this, but I would consider it more like a toy.
Yes.
I think Mike said last time it could create some good memes.
Right.
Okay. Well, that's great. Now,
Anything that doesn't have an objective answer,
correct.
right? If it doesn't have an objective answer, then it's very good at, because it'll give you a lot of ideas. It'll give you a good first pass.
Right.
But once there's an objective answer, now I'm checking everything. Anyway.
Correct. Now though, I see it not as a toy and more as a utility to assist in helping out, specifically in our industry, in the engineering industry, helping out the work. And an example of that is, in just a simple example of that is it, I had a case where we needed to pick what type of flow transmitter to use in a process, right? And I thought, hey, you know what?
Yeah.
I'm just gonna try. I'm gonna ask Grok. Just
Yeah.
ask.
Yeah.
Like,
Yeah.
hey, here is the process. What type of flow transmitter should I use? Grok, right? 2 years ago, nah, you would have got crap answers.
Right.
Is an instrument person that's experienced, right?
Right.
It was a toy, right? It
Right.
wouldn't have given you a real solid answer. It would have done all kinds of nonsense. It would have, quote unquote, hallucinated. Now, no, it'll come back with like a legit answer. Like it came back with 3 actual legitimate reasons to use specific transmitters and why to use them. One of those I didn't even think of, and I was like, "Oh wow, that's different," because now it's applying what I'm feeding it, and it's
Yeah.
actually building out its own scenario the
Yeah.
way I would do it
Yeah.
as an instrument engineer, right? That's a different level.
And I think that's great, and I hope we stay in that sweet spot, right? Because when I hear you say that, you know, where my head goes is back to what you were saying about the intent of like data that's collected on humans. What's the point? It's to predict something about you. It's to sell you something,
Correct.
right? And so the question becomes, what happens when you ask that same question, and now it steers you to solutions because it's being paid, right?
Yeah,
What
I mean,
happens
that
then?
could happen.
Yeah,
right?
for sure. I
Right.
mean, it's like,
Iverson
I hadn't
gets
thought
in
of this
there.
because
Yeah.
I wouldn't have thought of it because they're being paid to tell
Yeah.
me to think of it, right?
Yeah.
So
Gonna get some flow serve control valves
that's
in there.
right. That's right.
Flow serve's the sponsor.
Yeah. Okay. There you go. Why not? I didn't
Yeah.
talk bad about them. So
Yeah, no, I could see your point there, and that's a point well taken. I was impressed by that though. I
Yeah,
was like,
no, it's
oh wow,
great.
it actually took the time to think, kind of like an engineer would
Yes.
do,
Yes.
and say, well, this is the process. Here's these different types of valves, or not valves, but transmitters. Whether it's like a mag meter or coil or whatever, right? I think this is the best one for that process. You know what I mean?
Yep.
It actually did that, and
That's
I was-
amazing.
yeah, I was shocked, right? Because, like I said, 2 years ago, no, it wouldn't
Right.
even gotten close to doing anything like that
Right.
at all. So I do think that there is a bit, but that goes to the same thing we were talking about like 5 minutes ago. Is I came up in instrument engineering. I had to spec
That's right.
things, right?
That's right.
I had to design
Yes.
them. I've made mistakes.
That's what I was going to
So
say.
when it-
You've seen the
when
results.
when it spit it out, I was like, okay, I see where it's going with option 1. I see
That's
where
right.
it's going with option 2.
That's right.
I like option 3.
That's right.
How is a new grad going to do that?
They're not.
They're not. They're not.
No.
They're going to look at it and be like, I'll
Right.
just go with 1.
Yeah. I've heard of that before.
Yeah.
Oh, there's the name brand.
Yeah.
I'll take that one.
Right?
Yeah.
And they're not actually going to know anymore.
That's right.
Which is scary.
That's
too.
right.
That's scary.
A similar example, but it didn't have, I would say, as positive of an ending as yours, right? Was my brother was working on doing a two-phase calculation for two-phase flow, right? And he was looking at some spreadsheet that had some formulas in it. So he asked ChatGPT, what's the formula for this equation? Because on one sheet it had some coefficient, and then on another one it didn't, right?
Yeah.
And so he's like, what's the formula? So it came back and it didn't have the coefficient, and he was like, oh, okay, well, do you ever need this coefficient? It's like, oh yeah, you got me. You need this because it's important. And it's like, if you don't prompt it to ask again,
Yeah.
then you just take that and run with it because you're like, oh, it gave me the answer and I'm going to go. And like you said, you looked at it because you had that knowledge, just like he looked at it
Yeah.
to question it and say, are you sure?
Are you sure?
Are you,
Yeah.
this doesn't make sense to me. and it gives you a different answer. And that's a little scary, right? That's exactly the problem that you're highlighting is
Yes.
if you don't know any better, are you going to remain curious? Are you going to dig? Because once it gives you something, is that the right answer?
Are you just going to
Are
take
we
it
done?
at face value
That's right.
and then rock on?
And I'm not saying that we should just be constantly questioning, because I think there are instances where if you train it properly and it's got a closed system and it knows, what it knows and it's only learning on that information, very valuable. But once you've got these more generalistic things and it's just making guesses, and you're like, what are you talking about?
Okay.
Yeah.
Okay. Now the next wrench,
Okay.
I guess, in here is the concept we've talked about. You building that system to kind of go from the conceptual into the detail, right? Design.
Yes.
Using AI to do that. I think this is all great, down the right track and everything. How does that bridge from engineering projects in the project phase through the construction? Because I still deem construction, you're still in the project phase.
Okay.
In my mind.
Yeah.
Right.
Until it's handed over.
Until it's handed over.
That's right.
So when I say project, I'm through that entire project phase life cycle. How does that translate into operations? And where do you go from there?
So, I mean, I'll just tell you things that I've been thinking about.
Yeah.
That I think, and I think it ties back to number one, your first question of how does AI fit? With what we're building, we can validate way more than anybody could do manually right now, right? Mm-hmm. So, like a simple example, when I was doing process work, you'd have to size a vessel, right? Just a pressure vessel. And you had guidelines, and so you followed it, and you had 4 hours to produce the calculation, get it checked, and produce the data sheet. Mm-hmm. So you really only got like one shot at it to do that process.
That process, yeah.
And if you got an answer that worked, it was probably good enough. But you didn't run every possible solution that you could have gotten to size that vessel to make sure you got the optimal, right? Lowest, metal or whatever it is, right? That you were looking for to optimize that. You didn't run all of those because it would have taken you way more hours than you were going to get paid for. So nobody did it. Nobody does it. But with the solution that we've got, it will run every option, and it will give you that optimal solution
within the same amount of time, or even faster.
Less, yeah,
even
for sure.
faster.
Exactly.
Than original.
And so I say that to say that there are new methods for pressure drop in pipe. Like people are coming up with different formulas for some of these things as they do research and they come up with new methods, right? Are we implementing those? Or are we just sticking with the ones that we know because they've worked since the 50s and everybody's satisfied with it? I mean, come on. Yeah. Where did the criteria for pressure loss in pipe come from?
Yeah.
Is the cost of power still the same as it was whenever they came up with that? Is the cost of material still the same? I mean, there's some equation that was done for that. So where I see this kind of going is we can run every single flavor of formula that is coming up. Mm-hmm. And then if we work together with partners on the owner side, we can tie into their systems and say, okay, here's the 50 pressure drop calculation methods that we've got. Which one best correlates with this system that you've got? So that the next time you design it, we're using this correlation instead of the generic one. And you could start doing these types of things to start recycling and getting optimizations between the design and the operators, because they don't have that capability either. There's no tools out there that are doing these things for them.
No.
And so we could bring that together and start to become like that provider of choice that is then giving them that tailored solution just for their next facility. Yeah, or even for an add-on to the current facility.
Yeah, I would agree with that. I think part of the problem, I guess, there in the industry I'm going to push back on you a little
Yeah.
bit is I think the owners are doing that, and they do have tools to do that. But what they kind of do is, in my opinion, and I guess it's because they kind of have to in a way, is they basically have to re-engineer it and
Agreed.
use their own tools.
Agreed.
Where what you're saying is okay, well, if you have that all over here on the project side, then don't do that. Just incorporate that within the data,
That's right.
right?
That's right.
In within the processes
right.
that are already there.
That's right.
So the owner doesn't have to go through and kind of make their own system.
Well,
If in a way,
and
right?
when they make their own system, again, they're not going to do every flavor. They're going to do the common ones.
They're gonna
that
do the
people are
common
used to. It's like,
ones.
okay, this
Yeah.
is good enough, and that's the point. We can always get to good enough, but the question is like, can we get to a better future? And so that's the other point, is let AI sort of look at the data and tell you, hey, I think this correlation would be better than this one and this one, and
Yeah.
let it start doing those things and steering you to the answers, right? I mean, that's the point, is once you have kind of this system or this tool that can do anything really, then you can just feed it in and let the AI tell you what the results are. And okay, this is the correlation we should use in this system. This is this one for this one. I mean, we can do this across the board.
Yeah, and then you're getting to more of a true digital twin.
That's right.
Right.
And
Because-
you get the setup for the next one, right? I mean, that's the point, is you get it right for the current one, but then the next time you want to do one, you say, in this system, I want this design. In this system, I want
Yeah.
this. And now you don't have to do all the options. You could, but even if they wanted to go to a different company to do it, they could give them a better starting point to say, these are what I expect you to do.
Yeah, it's interesting that we're talking down that path, because what internally, right, between me and Mike and the team here, what I've called that space and been calling it for the last, I don't know, 10 years or so, is the engineering data ecosystem. And traditionally, like I was saying, operators and owners, they kind of had their space, and then the project space was over here. There was kind of like a wall almost. And what I see going forward, to your point, is that engineering data ecosystem bridges over that wall, in the contractors, the EPCs, and the owners are working within the same space.
Right? That's right.
And using the same technology, using the same data sets, right,
Yep.
To operate the facility, which traditionally, right, EPC does their job, engineers do their job, and then they kind of throw it over to the owner afterwards.
That's
right.
right.
And that's why I was saying it's not that they're not doing it, but what they do is they then have to like reverse engineer and
Yep.
come up with their own systems.
Yep.
Well, why do that? Why not everybody just work in that engineering data ecosystem together
That's right.
and utilize it all at one time?
That's right.
And that to me is the true digital twin, because you could do it not just for operations, but you could do it for your asset management. You could do it for your maintenance programs, right? Because all of that, it's funny. A lot of, and I'm going to get dinged on this one, I know, because I've been dinged several times in the past. But a lot of owner operators, that we talk to, they always think that the system of truth or the record of truth is like SAP or their asset management or something of that nature. And in my mind, coming from the kind of the same background that you are, as the engineering world, I'm like, no, it's not. Like, all of the information in those systems actually came from that engineering data ecosystem.
That's right.
So without it,
That's
those
right.
systems are not irrelevant, but they're not utilized properly.
Yep.
And what you're doing is you're just recreating information from a different system.
That's right.
Why do that? Why not just connect into it and utilize it the way it is? But I don't think in the past with CAD-based system or file-based systems that was easy to do.
Oh, I agree.
But now with data, authored, engineered data through enterprise level systems, that is easy to do.
Yes.
And you can utilize it that way.
Yeah, I think maybe I would think about it a little differently. I agree with everything that you said, but I think I would categorize it to where the engineering databases are not the system of or the source of truth. I think they're the source of belief. because of what I just said, right? Like
Okay.
we're creating something that is going to be close to what they're actually going to see in operations.
Yeah.
But it's because we're using empirical formulas, right? We may not be using the best method to actually know how the operation is really going to
Yeah.
work. But once you bring those together like you're talking about and you get that virtuous cycle, that's when you can actually have a true
That's when you can have that true
source of
I would,
truth,
I would
right?
agree with that.
Because
Yeah.
we think we know what it's going to be. We know what we built, but once
Yeah.
you turn it on, I can't guarantee that the pressure loss is going to match exactly what I did. I don't know. It's going to be close.
Yeah,
but
that's when
it's-
you tie those systems back into
exactly,
it.
and now we can start to
and
get.
now you got that circle.
That's
Yeah.
right. That's right.
Yeah. No.
I think you know, you could probably go down the the data handover and all of that stuff
Mhm.
as a rabbit hole. I'm going to throw a plug out. You might want to have Amy Lewis on here as a guest. She
Okay.
works for me. She's the head of our digital project execution.
Yeah.
And part of what you were talking about, how you have to, we just throw it over the fence. I mean, that's what her whole team does, is work on how you get a continuous handover, how it fits into all their different systems and populates it so that it isn't this disjointed handoff where you just dump and run, right? I mean,
Yeah,
that's, I can remember projects where they would send shipping containers full of binders and
Oh, yeah.
documents.
I
and
remember that
here
a
it is.
long
We just
time ago.
dropped it off and good luck. No, not now. I mean, what we do, and the good thing is it's part of our execution, right? So, when we think about handover and we think about like the project data warehouse and that common data environment, it's part of our execution. So it's not something that we're going to a client saying, "Oh, you want that? We could do that, but it's going to be an extra cost." It's no, that's just part of what we
That's
do,
just part of it.
and we'll just give you an output of it because
Yeah.
it's free for us,
Yeah.
right? And so that I think we have a different way of looking at it. I think it'd be a great conversation because I am definitely not going to be the right person to do it justice. I can keep it at that level, but she can definitely go a lot deeper if you want to talk through those things.
Oh yeah, I'll have to get something set up and talk
Yeah.
about that because I am interested in that because to minimize handover is one thing. I think you could get to a certain state, not now, maybe in the future, but you're going to get to eventually a certain state where there is no handover,
Agreed.
zero handover.
Agreed.
But then you get into some other stuff. That's definitely a rabbit hole.
Yes.
I agree with that.
Yes.
But I eventually think it'll get to a state where there is no actual handover in the traditional sense.
Yep.
Which I think we're moving there faster and faster. But that's maybe a conversation for another time.
Did we get to wrench number 3?
No, that was wrench number 3.
Okay, I wanted to make sure. I couldn't remember.
How does
All
it
right.
how does it fit into the
Okay.
owner operator and
Yeah.
world?
Okay.
Right.
Yeah, for sure.
Which you did good. You answered great.
Great. Yeah, you didn't yell at me, so that's
You
good. No.
kind of caught all the wrenches. Fantastic.
Yeah, I mean, it's not perfect, but there's, we're definitely making progress, and it's going well.
Well, good.
Yeah.
Well, I appreciate you coming out. I think we're about at our time.
For
I know
sure.
you're busy. I don't want to keep you waiting, but I appreciate you coming out and talking to us, and we'll have to have some conversations again in the future.
My pleasure. I'm glad you
Yeah.
invited me.
Thank you.
Thanks, Blake.